In previous videos, we discussed confidence intervals using the z-score. In this video, we're going to talk about a new type of distribution called the t-distribution. This is still a bell-shaped curve, but this time we're going to use what we consider degrees of freedom. This is also when the population standard deviation is unknown. So we're looking at it in the case where we don't know sigma, we know the sample standard deviation. We're still going to do confidence intervals with this, but first let's identify what degrees of freedom are. Degrees of freedom are number of values free to vary after a sample statistic has been used. And basically what that is to give us a buffer zone to make it unbiased, just like we have with our standard deviation for a sample, things of that nature. And we're going to use this formula right here. Degrees of freedom is equal to n minus 1. If you recall back when we discussed finding the standard deviation and the variance for a sample, instead of dividing by the capital N, the total population, we divided by an n minus 1. Well, that n minus 1 is the number of degrees of freedom and everything. So again, we're using the same type of formula here for the confidence intervals. We have a t here because it's t-distribution. Alpha divided by 2, still the same thing. We have S instead of sigma because we do not know sigma. Sigma is unknown. Everything else is the same. We calculate it the same way. Finding the t is actually much easier. We use a t table out of your textbook, and the t table, if you'll notice, has the first column being the degrees of freedom. Now if you'll notice, it counts by ones down to about 30, and then it starts skipping, and then we skip quite a bit between 40 45, and then we really skip. If your degrees of freedom fall between 30 32, in other words if it's 31, go to the lower number. If it's down here between 70 75, you actually go to the number that it's closest to. And down here between 500 1000, always go to the number that it's closest to. Up here in the smaller degrees of freedom, obviously you can get the exact degree of freedom. The confidence intervals, we have 5 that we're going to use: 80, 90, 95, 98, 99% confidence levels. And all we do is look at this top row at which confidence interval we want, find our degrees of freedom, and go over and see where those intersect, and that will be our t value that we use. So as I said, this table is much easier to read than finding the z-scores at times. So, but you will need to get used to reading this table. So let's try an example with this. A meteorologist who sampled 13 randomly selected thunderstorms found that the average speed at which they traveled across a certain state was 15.0 miles per hour. The standard deviation of the sample was 1.7 miles per hour. Find the 99% confidence interval of the mean. Okay, so we have that he sampled 13. So that's our n. That's the number sampled. And it found that the average speed was 15.0 miles per hour. Standard deviation for the sample was 1.7. So n is 13. Our x bar is 15.0, and our S is 1.7. We need to find our T. To find our T, we need to know the degrees of freedom, which is n minus 1. So that's 13 minus 1. So we have 12 degrees of freedom. We're using a 99% confidence level. So we come down here to our table. We're using degrees of freedom of 12. So here. And we're using the 99% confidence. So the T that we're going to use is 3.055. So I'm going to scroll down, and remember that our formula is x bar minus our T times S divided by our sample size, less than our mean, less than x bar plus T times our standard deviation divided by the square root of our sample size. Now let's plug in our numbers. Our mean was 15.0. The T that we just found was 3.055. Our standard deviation was 1.7, and we had a sample size of 13. And I'm going to fill in over here. The only difference is that I put a plus instead of a minus. And let me make that 5 a little bit better. Times 1.7 divided by the square root of 13. So I'm going to find this number first, and notice that this has 1 decimal place. So I'm going to round my number that I get to 1 decimal place again, because remember that my confidence interval needs to be the same as my mean, the sample mean. So I get a 1.4. So I have 15.0 minus 1.4 and 15.0 plus 1.4. And so I get 13.6 and I get 16.4. Now again, I need to apply this back to my problem, and I can say for a 99% confidence level, the mean speed of thunderstorms is between 13.6 miles per hour. Make sure that you put the units, and 16.4 miles per hour. Okay? Make sure when you're working with confidence intervals, the questions to ask yourself are, do you know the population standard deviation? If the answer is yes, then you're going to use a z-table. If the answer is no, you're going to use a t-table. And this is how you're looking at it. Do you know that information? If you know the population standard deviation, which remember is sigma, you're going to use a z-score, the standard normal distribution. If you do not know the population and you know S is given, then you're going to use the t-table. you calculate things the exact same way, it's just coming up with your margin of error that changes. And that change is actually huge when you're calculating these. So please pay attention and make sure that you know why you're doing this. Okay? Practice these confidence intervals and feel free to ask if you have questions.